All right, let's dive into the world of casting. Making cool metal things, from engine blocks to intricate sculptures. To do that, foundries need molds and cores. These are like the super detailed negatives of the final product, and what holds the sand for these molds together. That's where resins come in. They are the unsung heroes, the chemical binders. Think of them as super strong glue designed for extreme heat. Without these resins, the sand would just crumble. We wouldn't get those precise shapes we need, so yeah, resins are a pretty big deal in making metal parts. They are absolutely fundamental to the entire process. Now, not all resins are created equal. There are different types, each with its own set of superpowers and its own set of, well, not so superpowers. Today we're focusing on two major players. We're talking about alkali, phenolic resins, and Furan resins. These are workhorses in the casting industry. They help create everything from massive industrial components to smaller, detailed pieces. Choosing the right one can make a huge difference. It affects the quality of the casting, it affects the worker's environment, and it definitely affects the bottom line, so understanding them is key. So why these two? Alkali phenolic resins are often praised for their environmental benefits. They are generally friendlier on the nose and the planet. We'll get into the specifics of that. Furan resins, on the other hand, have been around for a while. They're known for their strength and speed. Foundries have relied on them for decades. Each has a distinct chemical makeup. This makeup dictates how they behave. It dictates how they perform under pressure. And under heat, lots of heat. Understanding the differences is crucial for any foundry. It's about matching the resin to the job. What metal are you pouring? How complex is the part? What are your environmental regulations? What's your budget? These are all questions that guide the choice. It's like picking the right tool for a build. You wouldn't use a sledgehammer to tap in a finishing nail, right? Same idea here. We need to explore their benefits. We need to look at their considerations. Let's get to it and break these resins down. First up, let's talk about alkali phenolic resins. One of their biggest selling points is a big one for workers. They generally have low odor and produce less smoke. Imagine working in a foundry. It can be hot, it can be intense. Reducing fumes makes a massive difference. This means a better, healthier working environment for the crew. Less coughing, fewer complaints about nasty smells. That's a win in my book. Anything that makes the job safer and more pleasant is a good thing. This quality alone makes them very attractive. Then there's the environmental angle. Alkali phenolic resins often mean reduced harmful emissions. We're talking fewer volatile organic compounds, or VOCs. And here's a kicker. Many are water-based. What does that mean for cleanup? It's simpler. You can often clean equipment with water. No need for harsh, aggressive chemical solvents. This is not only easier for the cleanup crew, it's also better for dear old planet Earth. Less hazardous waste to deal with. That's a significant step towards greener manufacturing, which is always cool. Now, let's get to the castings themselves. Alkali phenolic resins can deliver some seriously good casting quality. We're talking excellent surface finish. That means smoother parts right out of the mold, less time spent on grinding or polishing later. They also tend to produce low veining. Veining is those annoying little fin-like defects on a casting surface. Fewer veins mean a cleaner, more accurate part. It saves time and money on rework. Who doesn't want that? Better looking, better performing parts. But wait, there's more good news on casting quality. These resins provide good dimensional accuracy. The parts you make will be closer to the intended design specifications. They also boast good hot strength. This is crucial. The mold has to hold its shape when that super hot molten metal is poured in. And after the metal cools, good collapsibility. The sand mold breaks away easily from the casting. This makes the shakeout process faster and more efficient. It's all about making top-notch parts effectively. Okay, alkali phenolic sounds pretty great, right? But there are always considerations, no magic bullets here. One thing to keep in mind is their lower cold mechanical strength. This means the molds and cores might be a bit more fragile, especially before the metal is poured. So they need to be handled with a bit more care. You don't want them breaking during assembly or transport within the foundry. It's a trade-off for some of those other benefits, something to factor into your process. Another point for alkali phenolic is its limited storage life. These resins don't last forever on the shelf. You need to manage your inventory carefully. Use it or lose it is kind of the motto here. This requires good planning and stock rotation. You don't want to end up with a batch of resin that's past its prime. That could affect mold quality and performance. So, good logistics are key when working with these. It's just part of the deal when you choose this system. Now let's switch gears and talk about Furan Resins. These guys are known for their muscle. Furan Resins typically offer high cold mechanical strength. This is a big plus. Molds and cores made with Furan are robust. They can take a bit more handling, less worry about breakage before casting. They also provide excellent dimensional accuracy. This means your castings will be precise. They will match the design specifications very closely. For intricate or high tolerance parts, this is a huge advantage. Furan resins are also known for fast curing times. The molds and cores harden quickly. This can significantly speed up the production cycle. More molds per hour means higher throughput. That's music to a foundry manager's ears. They also provide good stiffness to the molds. This means the mold cavity resists deformation, especially when it's filled with that heavy molten metal. This stiffness is vital for maintaining the integrity of complex shapes. It ensures those intricate details are perfectly captured in the final casting. So, Furan resins are strong and fast, but like everything, they have their considerations. One of the main ones is higher odor. Yeah, they can be a bit pungent, and there's the potential for more harmful emissions compared to alkali phenolics. This means good ventilation systems are absolutely essential. Worker safety is paramount. You need to manage the air quality carefully. Proper personal protective equipment, PPE, is also a must. These are not things to skimp on. Protecting your team is job number one. Another thing with some Furan resin formulations is the presence of nitrogen and sulfur. These elements can sometimes cause problems. For example, they might lead to casting defects like pinholes in certain metals, especially steel, so you need to choose your specific Furan formulation wisely. Careful management of bench life is also important. Once the resin and catalyst are mixed, the clock is ticking. You have a limited time to use it before it starts to set. This requires good planning in the core shop. Furan systems often use stronger acidic catalysts to cure. These acids can be quite corrosive, so again, careful handling and appropriate PPE are critical. This also means the equipment used with Furan resins might experience more wear and tear over time. And sometimes the overall molding costs can be higher. The catalysts themselves can be more expensive. This is something to factor into your total production cost analysis. It's all about weighing the pros and cons for your specific situation. So who's the winner in this resin showdown? Alkali, Phenolic, or Furan? The truth is, there's no single best for everyone. It's all about what specific casting needs are. Alkali Phenolics shine with their environmental profile and good surface finish. Furans excel in strength and speed. Think about the metals you cast. Consider the complexity of your parts. What are your production volume requirements? And crucially, what are the environmental and safety standards you need to meet? The choice depends on balancing all these factors to find the perfect fit for your foundry. And that's a wrap for this video. I hope you found it helpful, enjoyable, and insightful. If you did, don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next one. Thanks for watching, and I'll see you in the next video.